Hello and welcome to the third video of a three-part series, where we will take a closer look at the GR1 granular synthesizer. In this video, we will take a deep dive into the menu to explain the functions behind all the settings. First, we need to address how the GR1 is structured.
The system is organized into three tiers: performance, patch, and sample. Let's start with the biggest tier, which is performance. Performance basically covers the entire system, which means all its global system configurations, all 32 patches, and all the samples that are used inside each patch. If you quickly want to store any system or patch changes permanently, you can do what is called a performance quick save. You can do a performance quick save by highlighting performance, holding down Shift, and pressing save. All changes will now be recalled anytime you start up your GR1. If you want to back up the system to, let's say, an external drive, you can do a regular performance save. Simply highlight performance, press save, and select your desired destination. The next tier in the overall system is patch. There are 32 individual patches that can be loaded up and accessed inside a single performance, and that also includes the local patch configurations and the sample that is used in the patch. The last tier of the system is sample. This only covers the audio samples that will be imported using a storage device or an audio sample that is live recorded into the buffer of the GR1. Okay, so now let's take a deep dive into the menu itself. This time we will start with the smallest tier, which is sample. Loop recording speaks for itself. When this is set to on, the user can record indefinitely as the recording wraps around in a looping fashion. When it's set to off, the user can record one full length of this buffer cycle. Start mode allows you to specify from which position the recording will be started. Current position initially starts the recording at the left side of the timeline, but can be interrupted by pressing the encoder again, freezing its current position. As soon as you resume the recording, the record position picks up where you left off. If wiper is selected, the recording will always start from the position the big slider is currently indicating. This can be useful if you want to record a variety of timbres within the length of one buffer cycle. Start will speak for itself, as it will always start the recording from the beginning of the timeline. Record level adjusts the recording level by multiplying the input signal with the set amount. If the record level is set to 0, the input signal will be multiplied by 0, so no sound will be heard. If the record level is set to 1, the input signal is not affected. And if the record level is set to 2, the amplitude of the input signal is doubled. Sample size adjusts the recording of the internal buffer in seconds. The minimum recording length is 1 second, and the maximum recording length is 112 seconds or 8 seconds short of 2 minutes. Clear sample also speaks for itself, which clears the current sample from the buffer to make way for a new recording. These instructions have covered the first of 3 menus of the GR1, so let's dive into the second one, which is the patch configuration menu. Starting off with the most exciting one of them all, the name text box. Enter the text box by pressing the encoder and scroll to the character that you want to edit. Press the encoder to highlight a character and edit the character by scrolling with the encoder. Confirm your chosen character by pressing the encoder again. Holding down the Shift button will transform the character into capital letters when scrolling with the encoder knob. If you are finished editing your patch name, Simply press Escape once to return to the patch menu settings. Up next are 10 features that will affect the grains themselves. The first feature of the list is sample mode. The GR1 has 3 sample modes to playback audio. The first sample is granular synthesis, which is the default playback mode of the GR1. Assuming that the concept of granular synthesis is familiar by now, we will just skip on to the next one. Audition mode plays back the sample as a traditional sampler. Most granular parameters will be ignored, however, the sample can still be pitched, filtered, modulated and played back in polyphony using a MIDI keyboard, for example. The last mode to select is tape mode. Tape mode emulates a play tape head that is being moved over a piece of tape. If you want to learn more about tape mode, please head on over to example 3 of the second video of this tutorial series called Making Granular Patches. And then we have spawn mode, which tells the granular sample engine how grains should be spawned when a new node is triggered. If you want to trigger nodes at a high rate, for instance with a sequencer or arpeggiator, direct and direct reset are the preferred settings. Direct mode will generate a full cloud of grains instantly, as if the granular engine had been running continuously in the background. This gives a new node on message way more punch directly from the start of the node. Direct reset mode is similar to direct mode, but all grains will start within the set spray area in order to concentrate the grains even more than the direct setting, which means even more punch. Gradual will generate new grains gradually based on the density speed. So this mode will take a little bit of time before a cloud of grains is filled up when a node is pressed. When a node off message is received and the release has fully played out, all the grains will cease to exist, so no grains will remain when a new node is triggered. Recycle mode is very similar to gradual mode, but in this case old grains will not cease to exist. They will remain frozen in time until a new node on message is received. Grain stealing has everything to do with ending grains in an efficient manner to save the computational powers of the GR1 CPU. The fast spawning and long-lasting grains will stack up until you run into the limits of what's possible, and this could cause audio dropouts. So the GR1 offers grain stealing to distribute how the GR1 handles the ending, or in other words, the stealing of grains. In order to smooth out and optimize huge granular clouds, grain stealing needs to be set closer to 1. Keyboard tuning allows you to tune samples to match the tuning of your MIDI keyboard. When this option is selected, the option listens to incoming MIDI notes of the MIDI devices that are already connected to the GR1. This way, if you know in what key the sample is tuned, you can easily hit the note on the keyboard and you are good to go. If you don't know the key of your sample, you can still find this out by using the following procedure. Hold down the escape button for 1 second to trigger a C-tune sign whenever you hold down a note on the MIDI keyboard. Now enter the patch menu, scroll down to the keyboard tuning option, enter it, hold down any note, preferably C in most cases, and scroll the encoder until both tunings match each other's frequency. ADSR pileup is a feature that we will be removing from future firmware. So for this reason we will skip ADSR pileup. Next in the list is Grain Key Sync. If Grain Key Sync is set to on, at least one grain will launch directly when a note is played. This way you always have a sound when a note is struck. If this option is set to off, the grain launch is independent from the note trigger and will be launched depending on the timing of the density parameter. The next option is Grain Clock Sync. Grain Clock Sync will synchronize the density parameter to an external MIDI clock signal. Hook up an external device or a DAW to send a clock signal to your GR1 and send the clock sync option to on. If this mode is set to on, the density knob can be used to multiply and divide the incoming clock signal to any desired time signature. Turning the density parameter will adjust the density multiplier, and if the shift button is held down, it will adjust the division of the density parameter. If Grain Clock Sync is set to off, which is the default setting, the density control will run in free time. Sample loop confinement allows you to limit grains and their length exclusively to the area defined by the loop start and loop end controls. A practical use of the sample confinement is when you have a recorded piece of audio but only want to focus on a part that you like. Resample anti-aliasing will turn on an anti-aliasing filter to increase the overall audio quality, but because this is a bit of a CPU heavy task, it may reduce the amount of simultaneous voices that the GR1 can handle at the same time. For this reason, anti-aliasing can be turned off. Granular glide is a personal favorite of mine, because it drastically changes the way how grains will respond to any pitch changes. If granular glide is set to off, grains will respond to any pitch change immediately, ignoring the assigned pitch that was given to the grain initially. But turning this setting to on, every grain remembers its original pitch and will maintain its pitch until it has reached the end of its lifespan. So if we would take our sine wave pitch modulation again, every grain that spawns will be given its pitch at that very moment, but will remain on that pitch without being affected by any further modulation. Next up are a few settings that only affect how the scan parameter operates. The scan key sync option will allow the scan position to be reset to the play position on every note event or not. So if there is a specific spot in your sample where you want to start every time, set it to on. If set to off, the scan position will continue to scan and wrap around, ignoring every new note on event. Legato mode only resets the play position on the first note played, ignoring any new note on message if it overlaps with a previous note. Scan loop confinement will confine the wrapping of the scanning position to the set confinement looping area. The loop area is set up with the loop start and loop end controls by holding down Shift and adjusting the size parameter for the loop starting boundary and the size curve for the loop end boundary. Scan mode can be set to 3 different modes on how it will react when it runs into the boundaries of the loop confinement. It can be set to loop, one shot and ping pong. Loop introduces a wrapping fashion. One shot will stop the scanning motion when it reaches its boundaries. And ping pong will allow the scanning motion to revert its direction to a back and forth motion every time it reaches a boundary. Next on the list is Scan Clock Sync. Setting the Scan Clock Sync to on synchronizes the scan movement speed to any incoming MIDI clock signal. As soon as a node is held down and a clock is running, the scanning position will start moving in sync with the tempo of that clock signal. When using this mode, the scan knob is used to set a clock multiplier value, and by holding down Shift, the scan parameter will set the clock divider value. The next 4 settings will configure how the play mode will react when play mode is turned on the front panel of the GR1. The Response to Play option will make a patch responsively to play mode or not. In some cases it might be useful to make a patch exclusively responsive to MIDI. For instance, when in multi-timbral mode, the grains of 2 multi-timbral parts can be launched using the play button, while the other 2 parts will stay silent and will only respond to incoming MIDI notes exclusively. With slider bass note, you can transpose the root note of C that is used in play mode to any other desired root note. When pressing play on the front panel, the GR1 initially starts playing its voices in C as its root key. Even if the voice pitch sliders are adjusted, those pitches are relative to this key of C. Set the root note or bass note to any other key to base your harmonic voice tuning to this new root note. Freescale allows you to free the tuning of the voice pitch sliders from the imposed scale below. Pitches will not be quantized to this scale, which allows you to tune the voices to any desired microtonal tuning you like. Play scale lets you set the scale on which the voice pitch sliders will quantize their pitches. Any notes that are grayed out will be ignored. Up next are 6 settings that will configure the FX of the GR1. The GR1 has several built-in effects: a delay, distortion, reducer and a reverb. Note that only one of these effects can be active at a time. As soon as you have selected your desired effect for the patch, map the corresponding FX functions below to the FX knobs on the front panel in order to control the effects. Filter mode selects which type of filter is used when using the cutoff parameter. The FX type can be set to a low pass, band pass or high pass filter. Sub Oscillator can be used to add an extra fundamental to the bottom frequencies of your timbre. The Sub Oscillator is polyphonic, and with the correct FX mappings to the knobs you can control both its frequency and its amplitude. Sub Oscillator Balance is used to balance the focus of amplitude when playing in polyphony. If the balance is set close to -1, the amplitude is more focused towards the lower notes of the polyphony, which adds more bass to a sound. If the balance is set close to +1, the amplitude is more focused towards the higher notes of the polyphony, which adds more treble to the sound. Up next are a lot of options that will allow you to configure the modulation settings for a patch. The LFO2 Delay Sync option enables you to sync the period of LFO2 to the period of the delay time. This way, a delay can be more interlocked with the settings of a patch if necessary. Cubic curves allow the user to have a lot more control in the lower range of the LFO amount parameter, which can be useful for setting subtle vibratos, for instance. This setting also affects the data entry in the modulation matrix. LFO 1 and 2 Sync will sync the individual LFOs to an incoming MIDI clock signal. Using the frequency parameter will set the clock multiplier rate. Holding down Shift in combination with setting the frequency parameter will set the clock division rate. Each LFO wave cycle can individually be synced to a node on event. When this feature is set to on, the LFO wave will reset to the beginning of the waveform on every node on event. When this feature is set to off, the LFO wave will ignore any node on event and continues to cycle without any interruption. The LFO 1 and 2 Max Frequency option sets the maximum frequency of LFO 1 and LFO 2. The default range is maxed out to 50 Hz in order to optimize the accuracy of the frequency parameter, but this range can be maxed out to a frequency of 100 Hz. Modwheel to LFO 1 and 2 enables the user to amplify all the set modulation amounts within an LFO using a Modwheel. This allows you to easily influence the level of a lot of modulation amounts using just one control. LFO 1 and 2 quantization quantizes the phase of the LFO waveform from a continuous signal into a stepping pattern. If LFO quantization is set close to 1, there is almost no quantization taking place. But as soon as you move the slider to the right, the waveform will be less and less discrete until the signal is broken up into a few steps. A really cool example is combining LFO pitch modulation with quantization and granular glide. LFO 1 to 2 cross modulation can be used to cross modulate the frequency or rate from LFO 1 with LFO 2. LFO 1's frequency will not be affected by the frequency of LFO 2, so the cross modulation only works in one direction. The modulation matrix is the complete list of all the modulation destinations in one single grid layout. It allows you to set multiple destinations per modulation source instead of the one-to-one routing which is available in the main screen. Highlight the modulation source by pressing the encoder, scroll to the destination value and press the encoder knob to edit the value. You can use the big slider to adjust the values. Push the encoder once to exit back to the row or press escape to jump back to the patch options. While the matrix offers you all the sources and destinations in one single overview, this might not be your preferred way of adding modulations if you want to work a bit more hands-on. Holding down one of both destination buttons for 1 second will allow both LFOs to access LFO matrix mode from the front panel. Now it is possible to set multiple destination amounts using the knob instead of using the matrix inside of the patch menu. MPE clipping limits the position to stop at the edges of the screen, which in some cases might be more useful than the position jumping all over the place. Now let's get into a more complex feature of the GR1, keyboard split mode. So what does it do? This feature splits up a keyboard range into 2 or 3 areas. Once a keyboard range is split up into 2 or 3 areas, we can assign each area with an own position where the playback will start playing. Let's listen to a sample that noticeably changes its timbre over time. In this one sample, we have a lot of timbres to choose from. The first thing that we want to do is to determine the size of our area by setting the keyboard split positions. Let's start with area 1. Highlight keyboard split and hit a key on your keyboard to decide where the keyboard will be split. We want to set pitch to on, so we have pitches that correspond with what we play on our keyboard. Now that we have split our keyboard at C4, everything below C4 will have its own position independently from every note starting at C4 and above. Head on over to position offset and decide by ear where you want grains to start launching. Once you have picked your positions, we have one last option, which is keyboard to position. Here we can determine how much the pitch of a note modulates the area position. The last menu that we will cover is the Performance menu. This menu configures how the total system responds to MIDI and knob tweaks and adjusts some visual feedback that the user might find useful or not. The first 4 options are the part MIDI channels. These 4 multitimbral parts can be set to listen to the same MIDI channel, so they all respond simultaneously to incoming messages, or parts can be set to an individual MIDI channel, so they respond separately from one another. If any of the part MIDI channel options is highlighted, holding Shift plus a slider swipe enables all 4 parts to be adjusted to the same channel at once. LED Brightness of course controls the brightness of all LEDs on the front panel. The Potentio Setpoint option enables you to lock a parameter until it is picked up at its last stored position. This prevents the stored value from jumping instantly to the new indicator position when a parameter is touched. Turn your parameter until the pickup point is met to unlock and activate the control of this parameter. The next option is Direct Shift. If the Direct Shift is set to on, the Shift button needs to be held down to access all the secondary functions like the voice pitch sliders or the voice patch volume. Direct Shift is set to on by default. When this option is set to off, the Shift button behaves like a toggle and will be released when pressed a second time. ADSR slider mode can be set to 3 options: ADSR, voice volume and part volume. The ADSR setting allows the sliders to function as ADSR controls, of course, but the voice volume will allow the sliders to control the individual volumes of the 4 play mode voices inside one patch. And in multi-timbral mode, the part volume setting will allow the sliders to control the volume level of each multi-timbral part individually. Velocity curve adjusts the keyboard's velocity sensitivity. Square root is the default setting and is adopted by most well-known synth manufacturers. This curve allows notes that are played softly to still reach a high velocity. If velocity curve is set to a linear curve, the keys need to be struck harder in order to reach high velocities. The option Load Sample Convert to 44.1 kHz forces the GR1 to convert every imported sample to its native 44.1 kHz sample rate playback. Loaded samples that are already 44.1 kHz will not be converted. Big Slider Controls menu allows you to make use of the Big Slider to adjust settings in the menu. Next in the list is MIDI CC Updates Visuals. Set this option to On if you want to keep track of the CC activity, which may be useful for diagnostic purposes. Set this to Off if you don't want CCs to visually inform you when controls are changed via MIDI. Patch Switch to Stop Grains will stop any playing grain when a patch is switched to another patch. DSP, or Digital Signal Processor Metering, toggles a bar in the main display to indicate the processing power that the GR1 CPU is using at any given time. Audio dropouts may occur around 90% of the CPU usage, and at this point the bar will also change color to red to indicate that the CPU is processing at maximum capacity. The pitch bend range can be set to any desired pitch bend range of up to 48 semitones. Large ranges are ideal for MPE controllers such as the Roly Seaboard. The MPE toggle turns on MPE support, which stands for MIDI Polyphonic Expression. In this mode, all MIDI channels are effectively superseded because all 16 MIDI channels are being used to control a maximum of 16 individual voices. Each voice now has an own set of MIDI control changes such as pitch bend, aftertouch, velocity and more. File Chooser Sound Previews enables you to audition samples in the file chooser before they will be used in a patch. Note that extremely large samples may take a while as they need to be loaded in order to play back the preview. Incremental patch saves will save patches in incremental steps like patch, patch 1, patch 2, etc. This is useful if you want to preserve intermediate steps in your work. To make use of this option, perform a patch quick save by highlighting the patch button and pressing Shift plus Save to save an incremental patch. Note that the very first patch needs to be saved as a regular patch first by simply using patch plus save. Send Precision CC will change the resolution of control change values from 7-bit CCs or 128 steps to NRPN CCs, which is 14-bit or 16,384 steps. Note that this only affects MIDI out and can only be used when using an USB host-to-host interface, as 14-bit CCs or NRPN is not implemented in the regular MIDI protocol. Check Firmware Upgrade will check for firmware updates on external drives and allows you to update without booting the unit first. It has the added benefit of also checking for updates from the tasty chip sites if a LAN cable is inserted. Onboard Chord toggle mode is another feature that we will remove in a future firmware, so for this reason we will skip the explanation of this feature.
Well, that's it for a 3-part series on granular synthesis and the GR1 granular synthesizer. Feel free to leave a comment down below to tell us what you think and leave a like if you enjoyed this video series. We hope you have learned something new, but if you have any further questions, please head on over to our website www.tastychips.nl or join our GR1 user group on Facebook. Both will be linked down below in the description. That's it for our series. Thank you all so much for watching.